Welcome to Chapter 8. I'm looking at building an op-amp rectifier, and so I'm going to just go through the steps to construct a circuit, and I'm just going to build the one on the right hand side and show you how to go ahead and build that. So first I grab my 741, I put it in the gap, and I make sure it's well seated. Then the next thing I want to do is, there's no power indicators on this, so I better make sure I add my power first. So I go ahead and add my negative voltage, and if I can go direct to the breadboard with my power and put it directly into my source, I cut down on the possible mistakes I might make trying to connect things later. So one connection for power on the negative side, that's pin 4. And then I go to pin 7 for the positive input, and again I use a short wire and go directly into the power supplied in the breadboard. And then next thing I look at here, let's do the easiest one, and that says add a ground connection to the non-inverting input. So I'll go ahead and add a ground connection and go straight again into the top bar, and that makes things pretty straightforward. Alright, next thing I look at, let's look at getting a signal to be put into this circuit. So I need a resistor, a 10K resistor coming out of pin 3 of the pin 2 of the op amp. So I go here and I go one set of holes above, and I'm going to go ahead and stick the other end of the resistor in this long line of holes, and then I just need to get power from my function generator over to this long set of holes. So I'll go ahead and I'll use a orange wire, and I can just plug it in anywhere along these 25 holes. Don't go down here because there's no connection across this gap, so I'll just go ahead straight into there, and now I've got my signal applied, and those 25 holes are all connected underneath, and then that's where my resistor is connected in. So now I have my signal set up. If you want to go across the gap, make sure to add a gap filler. So I go ahead and put a wire across the gap, and now I have a connection all the way up and down the entire breadboard. Okay, I'm going to want to monitor the output, so I'll go ahead and put in a wire that I can connect my Oscope to. So I'm going to pick green as my connections for the Oscope. And then I've got my input, and now let's go ahead and add the diodes and make sure I have some kind of output that I can monitor on the upper right hand side. So I'm going to go ahead and put my resistor in. My resistor goes into the inverting input, again pin 2, so I'll go ahead and put that in, and then I'm going to pull it down because that's where I want my output to come from, is somewhere different than in the mess of all the wires. And then I go ahead and I look, and I now have to have a diode that is going to have the negative side towards my resistor and the positive side towards my op amp output. And my op amp output is pin 6, and I want to make sure the negative side is towards my resistor, and I got it backwards, so I'll reverse that. The negative side is toward my resistor, and now I've got my diode installed with the resistor. And then I have one more diode I have to put in that goes directly from pin 2 to the output of the op amp, pin 6. So I'll put that diode in and realize that that one is reverse of the other diode. So I want the negative side, or the dash on my diode, to be closest to the output pin of my op amp, and that happens to again be my pin, or my connection number 6, and I'm just going to go directly across and feed into pin 2, and now I've got everything set up. So now if I want to monitor the output, which is between the resistor and the diode, I'll add a monitoring wire there, and then if I want to monitor the output of the op amp, I go ahead and add another green connection at the op amp output. So now I have all 3 monitoring leads connected, I'm going to add a ground for my Oscope lead. And so there's my grounding wire for the Oscope probe. And then I'll add another grounding wire down here. And I always pick the extreme set of holes, that way I don't make a mistake and accidentally put it in the part that's not grounded. Okay, so now we'll go ahead and add my Oscope probes, and I'll connect the Oscope probe to my green wire, and then make sure I have a well grounded connection down here. And so now I have my output connected, so I can go ahead and turn the power on and see if I've got a connection. And well, it looks like I've got a signal, but what is wrong? Well, I'm not triggering on the yellow, I'm only triggering on the blue. So if I go ahead and hit trigger menu and I pick channel 1, now I get a much stable signal, as long as I have a trigger level somewhere within the signal itself. If I'm below it, you can see how it free runs. If I'm above it, it free runs once again. So I go back, set it up so it's nice and stable. I take my other Oscope probe and I'll connect it first to the op amp output and make sure that it's also grounded. And then I look and I see what I have, and I have my half wave rectified signal with a little bit of negative voltage. And so that's why this is a much more effective circuit. So if I go ahead and raise my op amp output, you can see that there is some decrease or some voltage below. And since I'm in 500 millivolts per division, it looks like it dips down to about 0.5, maybe 0.55 volts, but then continues to go all the way up in the positive direction. So that's the op amp output. If I then go here and connect to the V out and look at that, now you can see the negative part is completely missing. And so that's a pretty well rectified signal, half wave rectification. And if I go ahead and set it at the same sensitivity as the yellow trace, these two would look the same, except this one's inverting the signal a little bit, or by 180 degrees. So that's why it doesn't match up with the peaks on the input. So I go ahead and go a little bit lower. When I want to analyze a signal, I like to make the trace fairly big, so if I want to make some measurements, I get a pretty good precision on the measurement of that value. I can also compare the op amp output and the V out and compare those. And so now what we see is a comparison of the op amp output and the V out. And so here's the difference, and I'll actually amplify these a little bit more. And so now you can see that the blue is my desired, the yellow is what's coming out of the op amp, and so you can see the additional drop across the diode that's in this circuit. So here we have our diodes, and so when we're looking at V out, we have to count for additional voltage in order to get across this diode, and so that's what we're seeing in this case is the negative 0.5 volts when nothing is going to get through the diode, and then on the positive side we have that plus about 0.5 volts, maybe 0.6 volts above the output value, again accounting for that drop, extra drop across that diode.